A very good morning to everyone. I think yesterday we all have posted about the number of students who have submitted the assignment. Uh, Actually, this assignment was given earlier when during our colleges, during a college, but I had not told you the deadline of writing the assignment. The assignment was on module 1 and some part of the module 2, fine. And then I could see that the videos what we have posted, okay, are not seen regularly by some of the students, fine. And we could see one student not seen the video of 3 to 4 lectures, fine. So if this happens, I know this is very difficult for us also, for you all also, but I don't know when the classes are going to start and how we are going to proceed with the syllabus. So this is what all the colleges are doing and all the professors are doing with different techniques. And since this module is basically a theory and completely theory, doesn't have any formulas, doesn't have any problems, doesn't have any derivations, so we are not going for any interactive classes. But it doesn't mean that you all are neglecting such videos wherein we are giving so much of information through these. And then maybe some of you all have got the book, some of you all have not got the textbooks along with you. So how are you going to study? This is very difficult. So in that case, at least if you go through these videos, you will have some idea about the topics which are there for your syllabus. And when you come back and study it from the textbook, then you will not face so much of problem. So because of that reason, we are taking such initiative. So we expect you also to involve in the same way, okay, and same way. And whatever quizzes and assignment we give it to you, you have to complete it within the time. Since you are at home, I don't think so, I hope so, you're not going anywhere outside. So if you are at home, see to it that you finish all those works within the deadline. Okay, that's what we expect from you all. Even we don't want to shout you or give any harsh comments on you. But if this continues, then I think we have to take any strict action, fine. So I had told some of you all to write the assignment twice, because I could see that I have submitted a video on Monday, and when I see it on Wednesday, after 2 days, that video was still not seen by some of the students, fine. So I understand that if you don't see that video on the same day, fine, I can understand. Next day, I can still understand. But the third day also, if you have not seen the video, it means that you are neglecting what we are sending. Okay, and some of y'all gave the reason that there was a net problem, there was no net pack, so we have to go outside and do the recharging. They were not allowing us to go outside. There are many other reasons people are giving. We are accepting those reasons, and we are allowing you all to take some time to complete the assignment, but it shouldn't happen, okay, the same thing again and again. Okay, so take this as a warning, fine. So whatever videos are we sending or whatever assignments we're giving, take it very seriously, fine. Okay, so then let us start now with the next type of communication interface. Sir has already explained the I2C interface, right? So that is inter-integrated circuit bus. So this there is some protocol to be followed for this bus. So sir has already explained about this. Let us go for the next type of communication interface, which is a serial peripheral interface. This is a synchronous bidirectional full duplex 4-wire serial interface bus. So there are so many words in the definition, starting with synchronous. Synchronous, as you all know, you have studied from digital electronics, right? There are two types of circuits, synchronous and asynchronous, counters, and so many. So what is synchronous is, it all depends upon the clock signal. whenever we say synchronous, the operation what happens inside this system when it is called synchronous, it happens on a single clock signal. A single clock signal will handle all the operation in the system. So single clock signal means what? A clock signal is a periodic signal. A periodic signal with a logic high and logic low, logic high, logic low, and so on. So when the system works on logic high, then during the logic high of the clock, all the logic highs of the clock, the system works, and during the logic low, the system doesn't respond. So this is what the synchronous means. Bidirectional, as you all know, so if there are two devices and there is an SPI connected between these two devices, the contains what is shared between these two devices is bidirectional, so it's not unidirectional, right? So once the data is sent from one device, at the same time another device can also send the data on the same bus. Okay, 4 wire full duplex, okay, and 4 wire. So 4 wire, it has 4 lines. We'll see what is that 4 lines in the next few sentences. It's a 4 wire serial. Serial means what? It will send the data one data at a time. So one bit will be sent, after that another bit will be sent, so it is a serial manner. Okay. Interface bus. The concept of SPI was introduced by Motorola. The SPI single master single slave system, okay, there is SPI is a single master and single slave. Okay, it cannot handle one master and many slaves. It can have only it can have one master and multiple slave system. Fine. So there has to be only one master. Fine. There can be more than one master, but only one master device can be active at any point of time. So suppose I imagine that the number of devices in the system, in that the devices are some devices are masters and some devices are slaves here. So slaves in the sense which receives only the data. Okay, they don't interact or they don't initiate any signal. Fine. So they are called slaves, and the one which are like, boss of the system, right? So they are called masters. Fine. So there are can be number of masters and number of slave devices in a system, but at a time when the systems are communicating, the devices are communicating, there can be only one master and number of slave devices. Fine. So SPI requires 4 signal lines for the communication. Fine. It has 4 lines, as I said earlier. There are 4 lines called MOSI, MISO. Okay. Then serial clock and slave select. So in short, we call it as MOSI, MISO. Okay. Then serial clock and serials slave select. So these are the 4 lines. Now why these 4 lines are important is, now you can say the first line says master out slave in. So what is the meaning here is, from the data is going from master and going into the slave. Fine. So signal line carrying the data from the master to the slave device. It is also known as slave input and slave data in. So what happens here is the data is going from master to the slave in this line. Fine. What is the next one? Master in, slave out. So master is receiving and slave is sending. So this signal line carrying the data from the slave to the master device. It is also known as slave output. So first one is known as slave input, since it was receiving. Now it is sending, hence the name is slave output. So serial clock, it's a line which carries the clock signal. As I said, this bus works on the clock signal. So there's a separate line which is given for the clock signal. Then we have one other line called save select. Now we have one master and number of slave devices, right? So at a time this master can communicate with only one slave device, and that is done by this line. This is called slave select. Each of the device will have the slave select. So by selecting that particular slave using this line, we can communicate the device with the master. So single line for slave device select, it is an active low signal. Remember, it is an active low signal. Active low signal means what? If we have to send, if you have to select a particular slave device, you have to send low on this line. So if it is high, it means that it is not selected for the communication. Fine. So we'll go to the next slide. Serial, it is continued. So this is what the bus interfacing of serial bus SPI. Okay, serial peripheral interface bus is connected. The bus interface diagram shown in the figure illustrate the connection of the master and the slave device. Now if you see here, there is a master, and what is that master? It is nothing but microprocessor or the controller, and you have two slaves here, slave 1 and slave 2. Now if you see the SPI connection, fine, there are 4 lines on each of the master and the slave devices, MOSI, MISO and SCL, MOSI, MISO, SCL, and select SS1 and SS2. SS1 for selecting the slave 1, SS2 for selecting the slave 2. Okay, now MOSI, MISO and SCL are the common lines, and slave selector from the master and between master and the slave. Now if you see here, MISO of the master is connected to the MISO of the common line. Fine, and this is the SPI bus. These 3 lines along with this SS1 and SS2 are called the SPI line. So MISO of, if you see here, okay, so MISO of the master is connected to the MISO of SPI. Okay, similarly MOSI of SPI is connected to the MOSI of this. So each of them are connected. Okay, each of them are connected in this way to the master. Fine. So you have MOSI, SCL, MISO and SS bar here, and MOSI, SCL, MISO and SS bar. So this is how they communicate. Now this is the connection of SPI bus to the master and slave devices. Next slide we'll see how this SPI performs the operation on the bus. The master device is responsible for generating the clock signal. So whichever is a master, that has to generate the clock signal. It selects the required slave device by asserting the corresponding slave select signal to low. Fine. And the data outline, that is MISO, of all the slave devices when not selected floats at high impedance state. So data outline means what? This is MISO line of all the other slave devices which are not selected will go into the state of high impedance. High impedance means the data doesn't flow through this MISO line, through these MISO lines. Only the one which is selected, on that line the signal flows from the master to the slave. The serial data transmission through the SPI is fully configurable. Okay, SPI device contain a certain set of register for holding these configuration. The control register holds the various configuration parameter like master or the slave selection for the device, baud rate selection for communication, clock signal and etc. The status register holds the status of the various condition for transmission and reception. Okay, so when we have to work with this SPI bus, okay, there are number of registers associated with this bus. Okay, at the hardware level, what we have to do while programming, these registers we have to alter. Okay, and what are those registers? There is a control register and there is a status register. As we know, the control register is used to control the operation of any system, right? So the control register here, what all it holds? It holds, for example, the baud rate. The baud rate is nothing but it will tell you at what rate you are transferring the data between the master and the slave. And another parameter can be in the selection, like which device is selected as a master and which device is selected as a slave. To select that, there is one particular bit. There are some bits for the baud rate selection, okay, and there are some bits for the clock selection, okay, etc. There are many other bits for the configuration. Now once you configure that and once the SPI bus starts working, there is a register called status register. This status register will hold the status of the SPI bus. okay, various status, okay, it will hold. And here in your syllabus you did not worry about what is the control and the status register here, okay. And if you have to study more on this, you can google it, or you can see this data sheet of SPI bus, and then you will understand what are the different bits of the control register and the status register, okay. So SPI works on the simple principle of shift register. So you all know what is the shift register. So this master and the slave devices contain a special register, shift register, for the data to transmit or receive. Both master and slave contains a simple shift register, okay, which will transmit the data from the master to the slave and vice versa. And the size of the shift register is device independent, okay, sorry, device dependent. Normally it is multiple of 8. So depending on the device, the shift register will be of that many size. Now microcontroller, if I am using as an 8-bit microcontroller, the special shift register used in this 8-bit microcontroller will be 8-bit. Okay, similarly, now if you have a slave device which is a 16-bit, then there will be a special register of 16-bit. Okay, during the transmission of master to the slave, the data in the master shift register is shifted out onto the MOSI pin and enters the shift register of the slave device through the MOSI pin of the slave device. Okay, so during the transmission, what happens here is from the master to the slave. Okay, so during the transmission from the master to the slave, the data from the masters, whatever the data the master has to send, it will master shift register is shifted out. So it will put the data into the shift register, it will load that and start shifting that shift register, and one bit will be going from MOSI pin to the and it enters the shift register of the slave device through the MOSI pin of the slave device. So it will send the data from MOSI pin of the master pin one bit at a time, and the same is received on the MOSI line of the slave device, and it will put into its shift register. Okay, and the same time the shifted out bit from the slave device shift register enter the shift register of the master device through the MISO pin. So here earlier I had told you something called full duplex. Full duplex means what? They are connected to each other. Now from the slave device, whatever the data we have put it into the shift register, the last data which is shifted, okay, it will not be wasted. That data will be again sent through the which line now? MISO pin. So the MISO pin is what? Master in and slave out, right? So whatever data is shifted from the slave, that is the last bit, will be again sent back on the MISO pin to the master device, and that will enter the shift register of the master. In the summary, shift register of master and slave device form a circular buffer or circular shift. Fine. When compared to I2C, SPI bus is most suitable for the application requiring the transfer of the data in streams. Okay, the only limitation in SPI is it doesn't support any acknowledgement. So here there is no acknowledgement given as in case of I2C, but here there is only the data transfer happening between the master and the slave devices using the shift register, using a very simple concept. Okay, so SPI is this having a full duplex 4-wire serial synchronous interface. It has 4 lines: MOSI, MISO, then slave select, and for the serial clock. The clock will be sent by the master device only, and there are 2 shift register in the master and the slave devices, and these shift register work in a circular manner or circular buffer. And then what else we seen? It has basically whatever the data sent from the master will be received onto the slave device, and the slave device whatever the data shifted out will be again passed on the MISO line, okay, to the master. So this how it works, like a circular shift operation. Okay, next we'll see what is an UART. UART is called Universal Serial Universal Asynchronous Receiver and Transmitter. So here UART based on data transmission is a asynchronous. It's a asynchronous form of serial data transmission. So there is no clock here. The data transmission happens in the asynchronous manner. It doesn't require a clock signal to synchronize the transmitting end and the receiving end for the transmission. Instead, it relies upon predefined agreement between the transmitting device and the receiving device. There is an agreement happens between the transmitting and the receiving device. Depending on that, there will be the data transmission. So there is no clock here. So here UART also has number of registers to handle this bus. Okay, so it has many control registers. There are many status registers. So the control register again can have the baud rate selection. It can also have how many bits we are transferring during the operation, because it is asynchronous. We have to tell priorly that how many data transfer is happening in this UART. So there will be a number of bits for the selection of the number of data bits to be transmitted. And then in control register there can be something called stop bit. So we have to say that we have to, after sending the data, we have to stop the transmission of the data. And how will the slave device understand? So when it is stopping it, so that all depends upon the number of stop bits. Okay, and then here it is, since it is asynchronous, we have to also see how reliable is the signal which is sent from the master to the slave, okay, on this UART bus. So for that there can be a bit for parity checking. So there will be a parity bit which we have to set during the transmission, and while receiving the data bits parity are calculated, and then it is checked with the parity bit of the control register. So this is how it works. Okay, so that's what is given here. The serial communication settings, what are the different settings is the baud rate, number of bits per byte, okay, parity, and the number of start bits and number of stop bits, and the flow control. Okay, for both transmitter and receiver should be set as identical. Okay, for both transmitter and the receiver, if you have a microcontroller on the other side where it is a transmitter and one device which is a receiver, then there has an UART between these two devices. Then you have to set these bits as a settings for both transmitter and receiver in the same way. Okay, the start and stop of the communication is indicated through inserting a special bits in the data stream. While sending a byte of the data, start bit is added first and then the stop bit is added at the end of the bit stream. So did you understand how the data is passed here? First there will be a start bit which is sent. Then after receiving the start bit, the receiver will understand that the communication is going to happen between the transmitter and the receiver. Hence it starts reading the bit of stream. Then once you have sent a complete byte, then next thing is you have to send the stop bit. So receiving the stop bit, the receiver will understand that this is the end of the data stream which is sent from the transmitter. So the least significant bit of the data byte follows the start bit. Okay, the least significant bit of the data byte follows the start bit. Okay, so this is that UART. Fine, and then we have start bit informs the receiver the data byte is about to arrive. This is what I told you. The receiver device starts polling the receiver line as per the baud rate settings. Fine, the receiver unit polls the receiver line exactly half of the time slot available for the bit. If the parity is enabled for the communication, the UART for the transmitting device adds a parity bit, 1 for the odd number and 0 for the even number. Okay, and then the UART after receiving the device calculates, as I said, calculates the parity of the bits received and compares it with the received parity bit for the error checking. Okay, the UART of the receiving device discards the start and the stop and the parity bit from the receiver bit stream and then converts the receiver serial data to the word and stores it in this in that particular device. Fine. So this is how the UART works. Fine. For proper communication of the data, the transmit line of the sending device should be connected to the receiving line of the receiving device. In addition to the serial data transmission function, UART provides a hardware handshaking signal support for controlling the serial data. Handshaking is nothing but the acknowledgement. UART chips are available from different semiconductor manufacturers. Fine. For example, is the National Semiconductors 8250 UART chip is used in most of the standard setting UART. Nowadays, most of the microcontroller are available with the integrated UART functionality, and they provide built-in instruction support for serial data communication. So even in our lab, our kit has this UART interface. So this is what the figure illustrates. There is two device, a transmitter and the receiver. There are two devices. Both of them can be acting like transmitter, the receiving device. Now if you see here, TXT of the transmitter is sent. TXT of this transmitter is connected to the receiver of the second device. Similarly, transmitter of this device is connected to the receiver of the other device. This is how the connection is made between the two devices if you have to connect through the UART. Okay, so we'll stop here. In the next class, sir will continue with the one wire interface. Thank you.